graders, we're going to go through lesson 3.3, which is about prime factorization, which is really writing the formula for a number, okay? Writing the formula similar to what we talked about with prime and composite. There are compounds, like water, that are made of elements, like hydrogen and oxygen. And the formula for that is a chemical formula which tells you how many molecules to use that makes the compound. So 2 hydrogens and 1 oxygen, when you put them together, you make water. All right? In a similar way, you can make composite numbers using prime numbers. We learned that prime numbers only have 2 factors. Composite numbers have more than 2 factors. So we can write the formula for a composite number like 165 using prime numbers. Now, all of our formulas are going to be formulas that you use multiplying, okay? These are multiplying numbers together. Sit down. Multiplying prime numbers together. So the first thing you do when you're given a number is to find a factor that goes into the number. Okay, let's take the number 165. And based on what we know about the rules of division, you can look at that number and see there's a number that goes into it. Right? What number goes into 165? Yes, it has to be evenly. What is a factor of 165? Danny? It ends in a 5, so we know that 5 is a factor. How many times would 5 go into 165?
11.
11 times? That would be 55. What would we have to do? Maybe we'd have to do this. 165 divided by 5. And 5 goes into 16 3 times. 3 times 5 is 15. Remainder 1. Bring down the 5. 5 goes into 15 3 times. Remainder 0. So, what number times 5 equals 165? 33. 5 times 33 is 165. Now, we write it this way so that we see which factors are multiplied in order to make the number above it. Okay? We're going to call this a factor tree. Because it's kind of like, this is the stem and then these are the leaves. We're going to keep making stems and leaves until we only have prime factors around the edge. Okay? Is 5 a prime number?
Yes.
Can we make any leaves to make prime numbers off of the 5? We don't need to, it's already prime. But 33 is not prime, is it? Yeah, numbers, what number goes into 33? How can you make the number 33? Melina? Well, what number would go into 33? 3. So we're going to use 3 and another number. 10. 3 times 10 is 30, so you're close. 11. 3 times 11. 3 times 11 makes 33, right? Yeah. Now, can we make any leaves off of these?
No.
No, because they are prime. These are all prime. 5, 3, and 11 are all prime numbers, so that's where we can stop. That's where our diagram stops. But once you have all prime numbers, now you write the formula for the number using prime numbers. And the formula writes the factors in numerical order. The prime factors, 3, 5, and 11. They're all prime numbers, right?
Yeah.
You with me?
So you circle that.
Nod your head if you're with me. Yeah, okay. Now when we multiply them out, they equal 165. So let's write them as a multiplication problem. 3 times 5 times 11. This is the prime factorization. Okay? If somebody says, what is the prime factorization of 165? It is 3 times 5 times 11. And when you multiply that out, it equals 165. Do you get the idea of what we're doing?
Yeah.
We're dividing out the number and writing it out in a diagram so we get to the prime numbers that make the number, and then writing them out in a formula. Okay? Put another example in your notes. Let's start with the number 180. Is 180 prime?
Yeah. No.
No.
No. Yeah.
It ends in a 0, so we know 10 goes into it. It's even, so we know 2 goes into it.
And 18.
5 goes into it. 18 goes into it. So we can factor this number by finding numbers that go into 180. Pick two numbers that go into 180 that you would multiply together to make 180. Jacob?
181.
Well, that's not going to help us because that's still 180.
Oh.
We're going to find two factors and start factoring this number to find the prime factors. Okay? So we can pick any two numbers except for 1 in itself, because that doesn't help us to get the other prime factors. What other numbers go into 180? Does 10 go into 180?
Yeah.
How many times?
18.
18. 10 times 18 is 180. So write those two. And then keep factoring, because neither of these are prime factors. So we have to keep going. Keep factoring until you have only prime numbers on the perimeter, or on the bottom.
Well, it's going to be a 2.
How, yeah, now we have to make the number 10. How do you make 10?
2 times 5.
2 times 5. Good. 2 and 5 are factors of 10. And they're prime, so we can stop. But we can't stop with 18. What goes into 18? Jacob?
9 and 2.
9 and 2. Now, is 2 a prime factor? So we can stop with 2. But 9 is not prime. What goes into 9?
3 and 6.
3. Yep. 3 and 3 make 9. So now look around the bottom numbers. They should all be prime. 2, 5, 3, 3, and 2. Okay? So I even like to circle the prime factors so I can keep track of how many there are and what they are. And then write the formula using exponents. Now, exponents tell us how many of the factors there are. So 2 is a factor, but how many 2's are there?
2.
2 2's.
2.
So we have to use 2 2's in our formula. Woohoo! And 3 is a factor, but how many are there? 2 3's. And 5 is a factor, but since there's only 1, we only need to write the 5. We have to put the formula in numerical order. So we didn't write it as 5 times 2 squared times 3 squared, or 3 squared times 5 times 2 squared. You have to put the factors in numerical order when you write the prime factorization. Okay? Go to your assignment on page 93. And let's start with number 1. It says copy the diagram, or copy and complete the factor tree. And we're starting with the number 40. Then they give you 10 as a factor, and 2 as a factor of 10, and 2 is a factor of this number, and you need to complete the table. So there's a blank here, and a blank here, and a blank here, and then we're going to write the prime factorization. So what should go in these boxes? What numbers are missing? What numbers are missing in our factor tree? Otto?
10.
10 times what is 40?
4.
10 times 4. And 4 is not prime. So what's missing in this box? Danny? 2. And 10 is not prime. What's missing in this box?
5.
Andrew? 5. Yep. Raise your hand next time. Now, do we have all prime numbers at the bottom or around the edge? So we have to use the prime numbers and write a formula. 2, 2, 2, and 5. Now write the formula. See if you can do it. What would the formula look like? Aiden?
It would look like 2 with an exponent of 3 and times 5.
Yeah. 2 with an exponent of 3, because we need to use 3 2's in our formula. And 5. What is this formula called in math? These are what? No, what? These are what type of numbers?
Prime numbers.
These are prime numbers, so this is called the prime factorization. Yep. Factorization is a formula. Okay? Number 3. Write the prime factorization of the number 18. We're going to skip number 2. 18. Write the prime factorization of 18. Go for it. When you're finished, look at the board. Try to do it on your own, but when you're finished, look at the board. See if you got it right. Alright, class, there's 2 answers on the board. What's the difference between the 2?
One of them is an answer.
What's the difference between the 2? Bella?
This doesn't make any sense.
The exponent to switch.
Oh, wait a second. Yeah, I wrote this one wrong. That's one of the problems.
Okay, so that's the 2 different ways that you can do.
Okay, good. Yep. They
The right.
have the same answer, don't they?
Yes.
what does this show? What am I showing you here? One of them starts with 2 and 9, the other one starts with 3 and 6. Is one of them wrong? Catherine?
It works because both 2 times 9 and 3 times 6.
Yeah, it works whether or not you start with 2 and 9 or 3 and 6 doesn't matter. Okay? Whatever factors you start with don't matter, because when you keep factoring, you'll get to the same prime numbers. There's more than one way to do this. There's more than one way to factor these out, because you will get to the same prime factors. Whoops. The same prime factors. There's just a different way to get to them. All right? But your formula should be the same. Maya?
Can you go sharpen my pencil?
Yep. Do the rest of the odds, starting with 5. Do 5, 7, 9, 11, 13, and 15 for tomorrow. So 5 through 15.
Odds.